Fire resistance is mandatory across nearly every engineered product. Today, fire performance is still evaluated almost entirely through physical testing late in development. When a material fails at that stage, the cost is high and timelines slip. Engineers are forced to test fewer options, eliminate materials late, and miss potentially better alternatives simply because testing capacity is limited. This creates inefficiency, waste, and slower innovation across every industry that relies on materials. This hasn't been solved because early-stage fire risk prediction has not historically been reliable enough to trust. Fire behavior is complex, material-dependent, and safety-critical. Without strong accuracy, interpretability, and validation, predictive tools could not influence real engineering decisions. Physical testing remained the only trusted option. Introducing Dravix. Dravix is an early-stage materials fire risk screening and prioritization platform. It helps engineers compare materials before testing, so physical experiments are applied only where they add the most value. Dravix does not replace testing, nor does it certify compliance. It is decision support, designed to improve how testing is used. Today, Dravix is a complete Phase 2 system running end-to-end with live model inference. This is not a mock-up or simulated output. The data pipeline, model, API, and UI are all fully connected and operating in real time. At the system level, Dravix integrates 4 tightly connected layers. Material inputs pass through a locked pre-processing and feature engineering pipeline into a trained machine learning model that predicts a proxy fire risk score from 0 to 100. That score drives interpretable outputs, a numerical risk score, a categorical risk class, and a resistance index. Control logic evaluates stability across material classes, and all results are exposed through a lightweight API that feeds directly into the user interface. This inference pipeline is the core of the system. Every decision flows through it. Dravix was trained on 718 real material samples across 3 material classes, with approximately 95 physical and engineered features per sample. In validation, the model explains over 92% of variance, with test R-squared around 0.98. The proxy fire risk score shows strong alignment with ignition physics, including Pearson correlation around 0.86, with heat flux and moderate inverse correlation with time to ignition. Importantly, relative material ranking remains stable across material classes, with higher uncertainty explicitly flagged for polymers. What you'll be seeing now is the live system. The model runs once at startup through a fast API backend. The UI sends real inputs to a predict endpoint, meaning there's no mock data here. As inputs change, the system returns a risk score, a risk class, a resistance index, and a plain language interpretation, all through a simple dashboard. And this allows engineers to compare materials and eliminate weak candidates before committing to physical fire testing. The current system is built in Python with a lightweight machine learning inference pipeline exposed through a REST API hosted on Railway, with a React-based interface deployed on Vercel. The entire stack is open source on GitHub, and detailed documentation with all links is available on our website. Dravix fits upstream of physical fire testing during materials exploration and early design, where decisions are still flexible and uncertainty is the highest. Early adopters include materials manufacturers, aerospace and automotive R&D teams, and research labs that evaluate large material search spaces under fire safety constraints. The system is modular by design. The same validated architecture can be extended to additional material classes and screening domains without redesign. Next steps focus on controlled pilot validation, expanding the dataset, refining interpretability, and observing system behavior alongside existing fire test programs.
Material selection underpins every physical industry. Fire resistance applies across construction, transportation, electronics, infrastructure, and more, a massive global market. Any improvement at the materials decision level scales across entire industries. Dravix is built as a platform that can expand responsibly as validation grows. Fire resistance testing can cost thousands to tens of thousands of dollars per material. Dravix is designed to reduce the materials entering testing by 30 to 60% during early development. Initial pricing is an annual subscription in the $5,000 to $15,000 range, making it cost-effective even if a single unnecessary test is avoided.
Dravix makes fire risk decisions earlier, clearer, and more efficient, without compromising safety. That is Dravix.